So potential outcome framework. So I hoped from the last class, you should understand. Understanding causal effect is quite important, but also very challenging task, or it's not very easy, because we cannot observe the counterfactual outcome. We only can observe the outcome that the treatment is realized, but we never observe the counterfactual outcome if we choose a different treatment. But if we want to observe the causal effect of the specific treatment, we need to know it's if we choose another treatment. What's the outcome if we choose another treatment? So that means we need to compare the observed outcome with the counterfactual outcome. The outcome that corresponding to the treatment which is realized, and the outcome, the counterfactual outcome, which where the treatment is not realized. Okay. So we will use the potential outcome framework. This is the framework that provides a way to help us to define the causal effect, or even quantify or estimate the causal effect. Okay. So the causal inference method we will learn in this class will all based on this framework, potential outcome framework. Okay. Okay. So I will introduce several notation for this potential outcome framework. So the first concept is treatment. So the treatment is an intervention that we want to understand its effect. We want to know its effect. Especially we want to compare this intervention with its effect with another intervention or no intervention. Okay. So we usually use this B to represent the treatment. And here the treatment could be a binary variable, a dummy variable that indicate whether an individual I receive the treatment or not. So it's binary, get treatment, not get treatment. So for example, if you want to know the effect of attending grade school on your earning, here the treatment is attend grade school or not. So D equal to 1 means you receive the treatment, you go to grade school. D equal to 0 means you do not go to grade school. Or have health insurance or not. You want to know the effect of having health insurance on your health status or healthcare utilization. So D equal to 1 means this individual I get health insurance, and 0 means not. Or even you can ask bigger question. The effect of democracy on economic growth. So you can define D equal to 1 means this country is implement democracy. 0 means is implement dictatorship. Okay. But the treatment is not just binary, get a treatment or not get a treatment. It could be multi-value or continuous variable. Like that is the D could be equal to S. Is a continuous variable. S is continuous variable. For example, you may not just want to know the effect of the go to school or not. Maybe you want to know the number of schooling years. You want to know whether you stay in the school for 1 year, for 2 years, for 3 years. How does this affect your career, your earning? So here the D could be equal to 1 or 2 or 3 or 4 or 5. So it depends on the treatment. So the treatment could be continuous, or the treatment could be number of children. 1 children, 2 children, or 3 children, or income tax rate, or even the money supply. But in the following slides, we will assume the treatment variable is a dummy variable. It's a binary variable, just for simplify. But you can extend or look at continuous treatment. Okay? So any questions for this? Okay. Then, after we define the treatment, then we will define the concept called potential outcomes. That's a key concept in this framework. So what is a potential outcome? Potential outcome is an outcome that we might be observed if individual choose that treatment. So this is a hypothetical outcome. It suggests that outcome might be realized in the world if this guy choose that treatment. So suppose we have two treatments for each individual. One is you get a treatment, another you do not get a treatment. So there are two treatments. Get treatment, not get a treatment. So that's a two-type treatment. So in that case, you will have two potential outcomes. Each potential outcome has their corresponding value of the treatment. So we will define Y1 is the potential outcome for the individual get a treatment. So here we use the upper script to represent the treatment status. Upper script. So the Y0 means potential outcome for the individual who decide not to get a treatment. Okay. So this is the if you have get such treatment, you will have potential outcome like this or this. Okay. So basically, how many potential outcome you have? Sorry. How many potential outcome how many treatment you have, you will have how many potential outcome. So for example, you might have two potential outcome based on whether you go to school, go to grade school or not. So there's a potential annual earning if you go to grade school. And there's another potential earning if you decide not to go to grade school. Okay. So again, the potential outcome could be YS. The treatment could be continuous. So it's possible more than two potential outcomes. So it depends on how many treatment you may have. So for example, there's one kind, if the S is the treatment is the number of schooling. So it's possible you have annual earning if you study in the school for 1 year. Annual earning if you study in school for 2 years, 3 years, 4 years. So it depends on how many treatment you have. You will have how many potential outcomes. Okay. So that's the potential outcomes concept. And then we can define another concept called observed outcome. So for each particular individual, we can only observe one potential outcome. Because you, at the same time, for the same individual, you can just observe one, they choose one treatment. So only one potential outcome will be realized in the world. Others are counterfactual, are unobserved. So we can define the observed outcome, can define that using this formula. So basically the observed outcome, why? There's no upper script, no upper script. The observed outcome is depends on your treatment status. If you get a treatment, basically Y1 will be realized. If you do not get a treatment, so this becomes 0, and Y0 will be realized. So observed outcome will depend on your treatment status and the value of potential outcome will be observed in the world. But only one potential outcome can be realized. So for example, if you get a treatment, Y1 will be realized. If you go to grade school, you can only observe the annual earning if you attending grade school. So this must have not the observed unobserved outcome. That's called counterfactual outcome. So in this case, is Y0 is counterfactual outcome. Okay. But if you want to know the causal effect, you need to compare these two. You need to compare Y1 and Y0. Otherwise, you don't know the effect. Okay. So any questions? Please? Okay. So then we can define the causal effects. So we will define various types of causal effects. So the causal effect is comparison between the potential outcome under different treatment, under each treatment. Specifically, we want to know the causal effect is the difference between the observed potential outcome and the counterfactual potential outcome. So the potential outcome if you get a treatment versus the potential outcome if you not get a treatment. So either one is observed, okay, and another one is the counterfactual, okay. Then we will use this framework to define the several types of causal effect. So the first is the basic one, is the causal effect for an individual. So maybe you want to know the Tom, maybe, for example, there's a guy called Tom. You want to know the effect of attending grade school on Tom's his annual earnings. Okay, so you might want to know this causal effect. Okay, for specific individual. So how we define this causal effect for individual? Sometimes we also call it individual treatment effect or individual causal effect. And that is basically is compare the difference between this guy get a treatment and this guy, the outcome if he did not get a treatment. So y1 and y0, these two potential outcomes. So for example, the difference between in the individual's earning if he attend grade school versus not attend grade school. But you can imagine only one will be observed because this guy either attend grade school or not attend grade school. So there must be one value is missing, one outcome is missing. Okay.
So if it's continuous, in this case, so like you said, the example, like if he has 1 year, 2 years, 3 years of grad school,
yeah.
How would we then expand that?
Yeah, that's a good question. That depends on the treatment effect you want, what kind of treatment effect you want to know. For example, if you want to know the effect of additional 1 year schooling on the earning. So here you may be compare y6 versus 5. That's additional one. But maybe you want to know the effect of additional 2 years. So you will compare different, yeah. But it will be make the notation become complicated. So typically we when we discuss this, we just compare get treatment or not. Yeah. But you can extend to the more general case. Yeah. So any other questions? Okay. Yeah. So you can imagine even this very simple question is hard to obtain using the observed data. Okay. So here I give you an example to demonstrate. Yeah, that's why we need to spend the whole semester to understand how to get a causal effect. Okay. Yeah, I also again use the example to evaluate attending grade school on the annual earnings. And here, imagine there are 4 people we want to know. We want to know the effect of attending grade school for these 4 people, for example. David, Tina, Mary, and Bill. Okay. So D is the treatment, as we just described. Attending grade school or not. Attending grade school, D is equal to 1, and otherwise it's 0. And so if you attend grade school, the potential outcome y1 will be realized. So y1 is the potential annual earning if this guy go to grade school. And y0 is the potential earning if this guy not go to grade school. So that's y0. So for the Davy and Tina, they are treatment group. They get a treatment. They go to grade school. So we can observe their y1. And for Mary and Bill, they do not go to grade school. They do not receive the treatment. so we can only observe their y0. So the observed outcome for David and Tina is the y1. We don't know their y0. Mary and Bill is the observed outcome is the y0. We do not observe this y1. But if we want to know the causal effect of the attending grade school on David's earning or Mary's earning, we need to compare its y1 and y0. We need to compare the annual earning if this guy go to grade school and if not go to grade school. So we cannot really get the causal effect for each individual. So what if we can observe the counterfactual outcome? That would be very easy. You don't need to register in this class. You can just take other course. You just do simple calculation, you can get the causal effect if you can observe a counterfactual outcome. For example, you know that if the David decide not to go to grade school, it will earn 2 million NT dollars, or this is the unit is million NT dollars. So if he go to grade school, he earns 3 million NT dollars. If not, 2 million NT dollars. So the difference is 1 million NT dollars. That's the effect of attending grade school on his annual earnings. And for Mary, whether she attend grade school or not, her earning is no difference. So all earn 1 million NT dollars. So that you can conclude is no effect of attending grade school on his or her earnings. Okay. So if you can observe the counterfactual outcomes, everything is easy. But the problem is we can only use observed data to infer the causal effect. Okay. And sometimes maybe you think I estimate the causal effect for a specific individual is not very useful because who cares effects for the baby or for the Mary? Yeah. You might more want to focus on the effect for general population. That on average, the effect of attending grade school on earnings. That's some researcher might or policymaker might more likely want to understand. Okay. So what is the causal effect for the general population? And we might not be use the individual causal effect, individual treatment effect to represent the causal effect for general population, because we usually the individual treatment effect, the treatment effect for specific individual might not really represent others people's causal effect. For example, David's effect is not really the same as the Mary's effect. So there's some effect heterogeneity. So we cannot just use individual treatment effect to represent the average treatment effect. Okay. So understanding the causal effect for general population is also quite important. Okay. So that is, you want to estimate the population average of individual treatment effect. You want to take average of each individual's effect to know on average what's the effect of the treatment. Okay. So here I give you some brief review. You might learn this from your statistics course. Expectation. So we usually use this E to represent the expectation. So expectation of this variable Y. And that basically say we want to know the population average of the Y. So we basically sum up all the value of this variable, the Y, and divide by the number of the individual we have. Take the average. That's called expectation of the variable Y. For example, you want to know the average income for whole population in Taiwan. So basically, you sum up all the income for each individual and divide by the number of individuals in Taiwan. So you can get this. So this is just a review.
It's like sometimes for some textbooks that will write -1. And so I would ask, the difference between?
Minus 1.
Yeah, like,
You mean?
就是 underfront 会写 n 减一 like in the
n 减
denominator
一
yeah in the denominator sometimes they will write n minus 1.
Oh, that could be when they calculate some sample average. For example, the variance, sample standard deviation or sample average.
So
Yeah. That's the related to the degree of freedom, so that's why they need to minus 1. Yeah. But here is a population, so that's the it's not sample. Yeah. It's not it's not estimate. You basically get every data point. You do not just draw some sample and calculate. Yeah, but that's a good point. You want to use Chinese, that's fine.
你民宿的时候才没有测，那个还是在那个，
那只有那个在
Variance 才有对。
样本编译数才有差，因为为了让最后一个数字要控制在母体平均数的时候。
对。
所以样本
样本的
对样本都是这样。
对样本都
对样本其实就会很长。Yeah, so you say the minus 1 actually is when you calculate the variance or standard deviation. Yeah. And but here I discussed the population. Yeah. Okay. And why we discuss this, because we will use this notation and basically we want to know the average treatment effect. That is the treatment effect for whole population. And so we have defined this is individual treatment effect. So for each individual arm. So here you just sum up all the individuals' effects and take the average. Sum up and divide by the number of the individuals. Okay. So if you can calculate each individual's effect, you basically can directly get the average effect for whole population. Okay. So for example, you want to know the effect of the 10 grade score on whole population's average earnings. That basically suggests you want to compare the average difference between the earnings of the same people if they go to grade school versus not go to grade school. So compare the average Y1 and average Y0. Okay. That's something you want to know. You want to calculate. So again, we use the same example. The population is these 4 people. The population is these 4 people. We want to know the effect of attaining grade school on these 4 people's annual earnings. So the previous slides, you say we just want to understand each individual's effect. And here is we want to understand these 4 people's average effect. So that's the different concept: individual treatment effect, average treatment effect. Okay. So how do we estimate the ATE, average treatment effect? Basically, is we want to know for these 4 people on average what's their Y1, what's their annual earning if these 4 people go to grade school, the average earning if they go to grade school. So basically we want to calculate this Y1. But for this example, we only know Davy and Tina if they go to grade school, what they earn. We don't know Mary and Bill. So we cannot calculate this. And for the Y0, we never know the Davy and Tina's because they go to grade school. We only can observe the Mary and Bill. But if we want to get the average treatment effect, we need to compare Y1's average and Y0's average. The average earning if they go to grade school, average earning if they not go to grade school. Okay. So we cannot get this effect. And if we can observe the counterfactual outcome, everything is simple. You can directly calculate by very simple math. Because on average, if these 4 people go to grade school, on average, they will earn $1.75 million. If not, 1.25 million NT dollars. And the difference is average treatment effect. It's 0.5 million NT dollars. So that means if they go to grade school, they get higher earnings. Okay? Okay. And that is the causal effect for general population, whole population. But sometimes you might want to estimate the causal effect for specific subgroup, subpopulation. For example, you want to know the effect of attending grade school on females' earnings. So that is a subgroup of people. Okay. So here I give you another review from your statistics course. It's called conditional expectations. So usually use the conditional expectation can help you to know the average for the subgroup, So we usually use expectation of y conditional on this variable x equal to 1. This means the average of y for the population that has x equal to 1. For example, x could be gender. 1 means female, 0 means male. So this means we want to know the average earning for female. Okay, we don't want to know everyone's. We just want to focus on x equal to 1. The people who has the characteristics that satisfy this. For example, female. Okay, so we just sum up the subpopulation. That is the individual who satisfy this condition, who is female or who has the x equal to 1. We just sum over these people and divide by the number of this type of people. Okay. So for example, the average income for those who have master's degree in Taiwan. That's one example. And we use this notation can define the conditional average treatment effect. We call CATE. And that's simple. We basically restrict our sample to those who are satisfied with this condition. For example, X is the gender, equal to F means female. So we just want to know the effect of attending grade school for the female. And we just sum up the individual effect for all the female and divide it by the number of female in the population. You can get this effect. You can get this effect.
Can I ask what is that?
This?
No,
Oh, this?
另外一个，
这个。
对，那个像
Tau. Oh, sorry. Here, tau, I do not. So thanks for this question. So tau actually I define in the very beginning, but I do not let you know. Actually, I forgot to let you know. The tau is equal to the individual treatment effect. So I just use tau. Say is this. And so you can say it's y1 minus y0. So yeah, so tau is y1 minus y0. Okay, yeah, thanks. So basically it's the average individual treatment effect over the female population. Okay, over the female population. Yeah, so for example, average effect of the attending grade school on annual earning for the female. So basically, you compare the average difference if this female go to grade, average difference in earning, if this female go to grade school and if not go to grade school, their average difference. But just for female, we just want to focus on female. That's a conditional average treatment effect for some subgroup people. Conditional, you are female. And we are especially interested in this conditional average treatment effect. That is average treatment effect on treated. Average treatment effect for treatment group. That is average treatment effect for those who get a treatment. Sometimes policymakers might want to understand this because, for example, you want to know the effect of attending grade school on those who already registered in the grade school. because you want to know whether a 10 grade school for these people are useful or not. That's the thing we might want to know. Or that sometimes we call it ATT. And this is a special case for the conditional average treatment effect, because here we just want to focus on the causal effect for the treatment group, for those who get the treatment, be equal to 1. So it's also very simple. You basically just care about those who get the treatment, the treatment group. You just want to know for the treatment group what's their annual earning if they attend grade school, and what's their annual earning on average if not go to grade school, and compare their difference. Okay, average difference. And we will spend a lot of time to let you know how to use the causal inference method to estimate the ATT, because typically policymaker or researcher might want to understand this treatment effect. Okay. And in this example, what is the ATT in this example? Basically, we just want to know the average treatment effect for those who get a treatment, because it's average treatment for a treatment group. That is, we just want to focus on the Davy and Tina because they get a treatment. And so how we get the average effect of attending grade school on their earning? Again, we need to compare for Davy and Tina what's their average potential earning if they go to grade school, and what is if they do not go to grade school, their potential earnings. And we only observe Y1. The Y1 is 2.5 on average. If they go to grade school, they can earn on average 2.5 million NT dollars. But the problem is, again, we do not observe their Y0. So we cannot get the average treatment effect for treatment group. Again, okay, we do not get ATT this because we have missing data problem here. So if we can observe the counterfactual data, counterfactual outcome, we will know on average if that do not go to grade school, they can earn 1.5 million dollars. So the causal effect for the treatment group in this case is 1 million NT dollars. They can get extra 1 million NT dollars if they go to grade school, compared not. Okay. So we know the causal effect for the treatment group, there's in opposite, we will also can define another causal effect for control group. So that's very simple. You basically replace your target to those who are not get a treatment, be equal to 0, and compare their Y1 and Y0. So that's very similar. So I do not describe a lot in this case. And I just directly go to the example. So in this example, we basically focus on the effect of attending grade school on the earnings for Mary and Bill, because here we want to focus on the those who do not get a treatment, the causal effect for the control group. So it's average treatment effect on untreated. We usually say it's ATU. And again, we can only observe the Y0 for the control group. We all know they can earn just 1 million dollars, but we don't know what if they go to graduate school. What's their potential earning if they go to grade school? And if we can observe, we can quantify. And suppose they again also earn just 1 million. So that means go to grade school or not have no impact on their earnings. So maybe that's why they decide not to go to grade school. Okay. So this we can define the average treatment effect on treated. Okay. So any questions? Okay.
Can you have like more than one condition, like it's T I equals 0, but also like it's female?
Oh yeah. You can do. That's just extension for conditional average treatment effect. The conditional on they are control group and female. So you can have a lot of conditions, but it's just extension for this concept. Yeah, true. Good. That's a good question. Any other questions? Okay. So just give you brief summarize a summary. We learned what is the individual treatment effect. That basically for specific individual eye, you compare the potential outcome if he get treatment or she get treatment or not. That's individual treatment effect. But this is not very useful because no one really care about specific individual. Maybe you care yourself. That's important for you. But people might more care about the average treatment effect because that's for on average for general population. And this is for those whole population. We want to know on average their potential outcome if they get a treatment. On average, if not get a treatment, what's the potential outcome? Compare these together. But sometimes maybe you just want to focus on specific subgroup, for example, the female. Then you just compare the females, their on average potential outcome with treatment, average outcome without the treatment. And within this conditional average treatment effect, we particularly want to focus on the treatment effects for the treatment group or for the control group, ATT and ATU. And this is just special case of the conditional average treatment effect. Because here the conditioning is we just focus on the treatment group and control group. Okay, so any questions? So that's the concept or the treatment effect. We might want to use the different causal inference methods trying to estimate, trying to identify. Okay. And I think so far you should deeply understand the fundamental problem of the causal effect, causal inference. What we trying to use the causal inference trying to deal with is the missing data problem. Because we can never directly observe the causal effect. We cannot. If we do not use any methods, there's no way to observe the ATE, CAT, ATT, ATU. The thing we just discussed. Because we never can observe the counterfactuals. We never observe the two potential outcomes for each individual at the same time. Okay. For example, for someone get a treatment, Y1 observed, Y0 is not observed. But if we want to know the causal effect, we need to compare these two. But we never do that. So the causal inference is the method trying to deal with this missing data problem. We try to use the data we can observe under some assumption, we can recover the counterfactual. We can recover something unobserved. Okay. Okay. So any question for this? And in fact, the potential outcome, this concept, maybe sometimes you might find is quite new, but actually it's deeply integrated in the economic theory, actually, or social science theory. A lot of theory actually imply this potential outcome framework. So that's I just let you know. For example, demand and supply theory actually use this concept, but you just don't really know. Okay. So for example, the demand function basically is represent the potential quantity of the demand as a function of the price. So basically, the demand theory or demand curve is basically suggests, given this price, what's the potential quantity, potential demand will happen. Okay. Like this. Demand curve. You learned this from Econ 101. Demand curve, supply curve. And what the theory says, basically say, if the price is P1, the potential demand is Q1. If the price is P2, potential demand is Q2. So price you can consider is kind of like the treatment. So given this treatment, there's a corresponding potential demand exists, Q1. Given this price, given this treatment, there's a Q2 is a potential exists in the world. But actually it's not really exists in the world. Only the equilibrium, when the demand and supply are equal, we can observe. We can only observe P star and Q star. Okay, we never observe the real demand curve. But if we want to verify this very basic theory in economics, we need to use some way to recover this demand curve to verify whether the price can really cause the quantity or demand decrease. That's you need to use some causal inference method to create the plausible counterfactual outcome to recover this relationship. You cannot just directly use the observed outcome to get this to verify this theory. Okay. Any questions? Okay. So this may basically say theory and empirical is have very strong relationship. Okay. So the framework so far we discussed actually depends on very important assumption. That's so-called stable unit treatment value assumption. And basically, this assumption is say the observed outcome is only depends on yours treatment, your self treatment. It's not depends on other individuals' treatment. Because we define the observed outcomes only depends on individualized treatment or not. He get treatment or not. It not depends on his friends' treatment or not. But in some case, the observed outcome should be depend on the other people's treatment. Okay. So basically, this framework is rule out possible treatment effect from other individuals. That is some kind spillover effect or externality. We exclude such thing. But we have to do that. If we do not rule out these things, everything will be very complicated. So I will just show you why we have to do that. So suppose now your observed outcome or potential outcome is also depends on or defined by your friend's treatment status. Then you will have more than two possibility of your potential outcome. So for example, you have to define, if such case, you have to define your potential outcome as the following. You just add one person treatment. For example, your potential outcome will become y11. The first one is depends on your treatment. And the second one is depends on your friend's treatment. So y11 means you get a treatment and your friends get a treatment. What's the potential outcome in that case? And so very similarly, y10 means you get a treatment and your friend does not get a treatment. And y00 means you and your friend both are not get a treatment. So you just add one person. If you add another, the number of potential outcomes will become much more. So it makes things very complicated. But in some situation, you might need to consider this. For example, your health status might depend on your smoke or your father and mother smoke. Yeah. So in that case, this framework maybe is not very convincing. But if you want to do this, there's no enough tool until now can deal with such case.
So for potential conservative, for example, so like your parents is like your mother went to graduate school, so you can have them as a teacher if
Yeah, that's possible. But in that case, actually, your mother's, in that case, this relationship is not very strong compared to this. Yeah. Yeah. So, and also, there's several tools can try to control this. For example, when you run the regression, you can just add the variable for your mother's education level. You basically compare the people who have the same parents' education level. Yeah. Yeah. So you can try to eliminate these things. And also you can try to choose the example that's not have a lot of externality or spillover effect. Try to avoid this. Yeah. Because there's no current literature, current knowledge actually cannot really deal with this problem. That's why we need to make these assumptions. Your outcome, your observed outcome depends on yourself, your treatment theory. Any other questions? Okay. So I let you know several conditions might happen, such things. For example, if the treatment has some contingent, or for example, getting the vaccine, COVID-19 vaccine. So the effect of being vaccinated on people's probability of getting COVID is also depends on other people have been vaccinated. So go very extreme example. Even you don't get vaccine, you do not get any treatment. Thailand. But if everyone get the vaccine, everyone get a treatment, you kind of get treatment in that case. So your treatments, your outcome, the probability of getting the COVID is also depends on other people get the treatment or not. If the treatment can is a contingent. Or sometimes there's something called displacement might happen. Like, for example, the type A CD increase the number of police. It might affect new type A CD, the criminal activity in new type A CD, because a lot of criminal activity might move to the new type A CD. But actually, new type A CD does not implement any new policy, do not receive any treatment. But his neighborhood changed the policy that might affect new type A CD's outcome. Or treatment might have some communication. For example, your brother watched the advertisement in the YouTube and tell you, oh, there's a product is very good. So even you don't watch the YouTube, watch this advertisement, you kind of get affected. Okay. So that's also another example that might violate this assumption. Okay. But so far, actually, we will keep this assumption. It's maybe problematic, but until now, statistician or econometrician or economists cannot really deal with this problem. Okay? But recent literature trying to deal with this, try to make this assumption weaker. Okay. Okay. So if you are interested in the thing in this slide, you can read the textbook, Mastering Metrics, Chapter 1 and 2, and Most Harmless, Chapter 2, or this new textbook, Chapter 4. So if you want to do some extended reading, you can consider read this. Okay. So any questions? Okay. So if not, let's have a break.
Oh, you mean like gentrification?
这这样的话是内生性的，
不是内生性，这个就算没有内生性，也会有这个问题，就是等于是说啦，你的回归或者什么要再考虑其他人的 treatment， 才可以确保你估出来的 effect 是纯粹是来自于你的 treatment 造成的，对，有点像这样子，但它不是内生性的问题，就是对。
Excuse me, Professor, the readings they are on the web page.
Yeah.
Okay, so
Web page. Oh.
On the in the web page.
Yeah. I put in the web page for the textbook.
Oh, okay.
Yeah. Oh, but the textbook you might need to buy a textbook if you want to read. But I think this is they have online version.
Okay.
Yeah. This
Okay.
people might have some PDF file or something.
Okay.
Yeah. I can also. Yeah.
Thank you.
好啊好啊。那我这边要做。这边倒不用讨论他薪资高低，就是专心讨论他管控的。虽然你后面会给他们的，就是说，但你后面其实比的也还是work from home高的跟低的，他们对于这次疫情的冲击是会比较低。我到刚刚才知道。对，所以，但你这边讲的只是女的，平均来说比男的低。但它并不一定是因为它比较容易有管控这件事情造成的，对，或者而且也有可能因为它比较可以管控，它在这次疫情受影响的状况会比较轻，对，这个，对，因为你看，对，或者他做就是属于文书类型，文书类型其实他不一定要去，对，但是你这边其实就是专心讨论那个不同类型的人他work from home的能力的比较，其实也就可以，你不用说要讲他们的薪资，因为这个又是一个很大的问题，就男的跟女的薪资为什么女的就是比较低这样？对。真的很多漂亮的教室。
教育是跑步的，但是我记得是那个县市的，还有那个全职工程师是因为他们有办法，因为全职工程师开始就是
你就归类就是35以上就是全职，35以下就是非全职。对，这样就不错。你就分2类是也可以。你刚刚意思说太多类，你知道怎么分吗？对。哦，那你就对那个你没办法，那你就是要一个一个，就是以这个县市等于1或这个县市等于3或这个县市等于4，这个非常里面这个叫或，就是有一个要以上。不行，它是用以上。对，就是这个用这个。对。你看它，对它，而且是以上，就是一个看起来像1的东西。你要去的。它这个就是它的或的意思。然后我顺便教你就是说，它这个就是 and， 就是看这个是或。这个是对，这是或，然后就是一样，这是什么荷兰？对，这个或者是看。and 或 or， 这是 or， 然后这个是。对，这个就没办法，你可能要一个或，然后回类。对，为什么你们是经济系吗？对，我也疑惑为什么经济系，但是这个适合经济系修啊，这是可以修的，因为我是有些是在台大经济系有教，所以其实本来就是经济系。
没有开始继续做。
哦，因为我正大这边是在运动经济这边上，就只是我没有在经济开的课。
我们课不是运动经济吗？
有啊，就是这个 IMS 学生。
我不知道。
有，就是收国际生啊，有一个经济的学生就收国际生跟一个本地生。对。你们第一堂来，有些人第一堂哦，
第一次来找教室找的话，
我们刚刚就在找教室。
是啊，但你可以看投影片啊。但基本上这门课就是教一个，主要就是要教一份期末报告。对。然后这个报告就是也不用太长，就是2000字内，但是它就是要做一个实证的研究。对。个人的报告，对。因为这个报告你可能接下来有可能变成你可能写硕论的一个基础啊，或者是你觉得这个方向不对，你就也知道不要做这个，也是一个学到一个东西，对。那就是用课堂上教的这些方法，对。那里面这个课所有要做的事情都是为了要写这个报告，比如说你们会有一些 compulsory 的 office hour。就是在跟我讨论那个题目，然后大概会有2次上台报告，就是报告给同学听。但是在这个之前，就是会先跟我讨论，然后还有3次的作业，主要让你练习怎么用 Stata 跟 R， 就是我会教 Stata 跟 R。那作业不是叫你们解什么问题，主要就是用这个学到的指令去处理你们 term paper 要用的资料，对，所以所有在做的事情就只是在做一件事，就是弄那个 term paper， 因为要在1学期弄出一个有点样子的 term paper 蛮困难的，对，所以我不太希望就是你们还要分心做别的事情。
他那个 data 是都要还是
不用？你的 term paper 资料分析要用 Python 也可以，或别种软体都可以。只是我会教这2个，就是从头开始教。那只是让你们知道怎么用这2个软体。对，但是我不管你们你们要怎么处理你的资料。哦，但是那个作业就是要用这2个软体做，因为这个要让你们学的。对。哦。
Do we have like a more recent version? Because like I have 14.2 and it crashes sometimes.
Yeah. I will give you the link to get the software. Yeah. So I will announce. Yeah. But you can also try to find the source by yourself. It's still possible.
They want us to show feet on the internet.
Okay, so let's continue the class. So next class we will discuss the concept called the selection bias. Okay. So you might know now the causality actually is defined by the potential outcome. So we need to use potential outcome to define the causal effect. So basically, when you discuss the causality or causal effect, is compare two potential outcomes. The potential outcome with the treatment, potential outcome with another treatment. Okay, so the causality is defined by the potential outcome. That's a very important concept. Not by the realized outcome, not by the observed outcome. Okay. Some people might confused by this, but from the last class, I think you should know the causal effect or causality is based on the comparison of potential outcome, not the comparison of the observed outcome. Okay. But the problem is, in fact, we cannot observe all potential outcomes. We can only observe two groups of people, one get this outcome, one get another outcome. That's something we can do. So by using, if we do not use any method, just directly using the observed data, observed outcome, we can only establish the correlation, the associate. Sometimes we call association. We just know this variable and this variable, they move together or not. But we don't know whether this variable really caused this variable happen. Okay. So that is, if we use the notation we just described in the last class, basically the observed, if we just use observed outcome, observed data, the thing we can do is just like this. We can just compare those who get a treatment is observed outcome, and the people who choose not to get a treatment, their observed outcome. We can compare these two outcomes, their difference. But this difference, later you will know, is not give you the causal effect. It's the causal effect plus some bias, selection bias, that we will show that. And this bias basically is reflects the treatment group, those who select to the treatment, and those who select to not get a treatment. These two groups of people actually are quite different. This difference will create a selection bias. That may confound the causal effect we want to estimate. Okay. So here I give you, just let you know, observed outcome, it depends on two things. One thing is your treatment status. So if your treatment status is different, you will get different observed outcome. That's very easy. And it also depends on the potential outcomes value. So if you find someone's potential outcome, the observed outcome is different, it might represent their treatment status is different, or their potential outcomes value is different. Okay. So that's something I want to emphasize because it's well related to the concept we will discuss later. So if we find two individuals have different observed outcome, why? It could be due to two things. One is these two groups of people receive different treatment. One get a treatment, one do not get a treatment. And that's something we want to know because this, if the observed outcomes difference is due to they receive different treatment, that's basically say it's a causal effect of the treatment. But sometimes even they are all receive the same treatment, maybe the value of potential outcome are different. Okay, so what does this mean? That is, suppose both are all receive the treatment. We just compare the same potential outcome for these people, individual I and individual J. These are the same type potential outcome, but their value might be different. And this difference is not due to the treatment because we compare the same treatment's potential outcome, all Y1. So this difference is reflect other difference due to other factors. Okay. So if the observed outcomes difference between these two groups is due to their two groups of people, their potential outcomes value are different, that is not the causal effect of the treatment. That is due to the selection bias. It's because these two group of people, they are fundamentally are very different, except for the except for the treatment status. They have other things are different. Okay. That's something we need to try to deal with. We try to eliminate this. Okay.
Yes. So you said if it's all observed outcomes, then it's a correlation and not a causation. Is that what you said? In the beginning.
In the beginning, it said if we just use observed outcome, like this, we just compare two group of people, their observed outcome. This just gives us the correlation. It's not causality. Because their difference it's not purely reflect the causal effect. Also have some bias, called selection bias. And this bias is due to other difference between those who get a treatment and those who decide not to get a treatment.
Oh, okay.
Okay.
So the other slide, the reason why it's causal is because it's both they got the treatment. So here 3i1 minus 3i0, but then if you look at the other slide that you were just on.
Oh yeah,
It says,
because from the last class, the causal depends on the potential outcome. Because we need to compare these people, the same people, if they choose get a treatment and not get a treatment. But the thing we can just use is observe outcome. And I just say if we just compare the observed outcome, they will not give us the causal effect. It's just causal effect plus some bias. If we do not use any method to eliminate this bias, we do not get a treatment, a causal effect. Any other questions? Okay. So this just show you what I just said before. The observed difference in average outcome actually is the causal effect plus selection bias. So the thing we can do is we compare the treatment group and control group, their observed outcome. One. And this term can decompose to two terms. We just do this trick. We add this term and minus the same term. So actually there is no change. Okay? But you do some rearrange, they will give you some meaningful expression. The first term, if you just combine these two, is the average treatment effect untreated. Because this is the treatment groups. If he get a treatment, the potential earning. If not get a treatment, the potential earning, potential outcome. So that's the causal effect. So this term can get the causal effect, but plus this term, selection bias. If this is not zero, you do not get the causal effect. So what is this term? This term is say, for those who get a treatment and for those who do not get a treatment, those who choose to not get a treatment, those who choose to get a treatment. If we compare the potential outcome, both are not get a treatment. So you can consider this is the outcome if these two people do not get a treatment. For example, you compare the people who go to grade school and those who do not go to grade school, their earning if they do not go to grade school. So it's kind of like the initial earning, initial condition. They all not go to grade school. So this difference is not due to whether they go to grade school or not. Because we all compare the potential earning if both group of people, they do not go to grade school. So if the difference in the observed difference is due to the treatment, this term should be zero. Because we all compare the same treatment. So if this term is not zero, either positive or negative, is not zero, that means except for the treatment itself, other thing might create a difference. Other thing. And this difference make their potential outcomes value are different. So you can consider this y0 is a function of your family background or ability. So for those who choose to go to grad school, maybe they from higher social class, have higher ability. So their y0 is always bigger than those who do not go to grad school, their y0. They even don't go to grad school, they can earn more than those who not go to grad school. And that means, this bias means fundamentally, these two group of people cannot be comparable. It's not comparable, okay? It's not apple to apple comparison. So the causal inference method we learned in this class is try to minimize this bias. We try to find a lot of method, difference in difference, regression discontinuity design, is all try to minimize this selection bias. And then we can use observed outcome. The thing we can observe just y. Use this to get the causal effect. Okay? So any questions? Okay. So here I just use the same example to emphasize the points I just raised. Try to use some number to let you know. So this you should understand. The observed correlation association of the two variables is not necessarily sufficient condition for the causality. So in the graduate school example, basically, if you do not use any method, you can just compare those who go to grad school and those who not go to grad school, their earnings. So what is this comparison? Is basically you compare Davies and Tina's average earning is $2.5 million with Mary and Bill, because these are control group. They select not to go to grad school. That's their choice. And due to this choice, actually they have selection bias actually. So you can do just compare this term and this term, and you get the effect, some estimate for the causal effect. But this is not actually is $1.5 million. But this term actually does not really purely reflect the causal effect. So what is the causal effect we can get is, suppose we interested in the causal effect for Davy and Tina, the treatment group. So what the right thing we want to compare is we want to compare Davy and Tina if they go to grad school. That's what we can observe. And if not go to grad school, what's their earnings? And their earnings, suppose on average is $1.5 million. And compare their difference. And it's $1 million. And this is not the same as the observed difference between treatment group and control group. Because the thing we want to compare is, we want to compare Davy and Tina if they make different choice, rather than Davy and Mary and Bill. Because Mary and Bill, their observed outcome cannot be a good counterfactual outcome cannot represent counterfactual outcome for the Davy and Tina. Okay. And the remaining difference is selection bias. You can say in this example it's 0.5. So what is the selection bias in this example? It's basically, say, for Davy and Tina, those who get a treatment, their potential earning, if not go to grad school, actually are very different from the Mary and Bill. So we cannot use Mary and Bill's their observed outcome to represent what if Davy and Tina do not go to grad school, because they are not the same. So there are some 0.5 difference. So this basically in this example is say Davy and Tina may be smarter, or they have very big better family background. So even they don't go to grad school, they still can earn more than the Mary and Bill under the same condition. So this is under the same treatment. So this difference is not due to the treatment. It's some other things. It's not causal effect of the treatment.
Is that related to the stable unit treatment value assumption?
No. It's but I see you raise an interesting point. If their treatment also depends on other people's treatment. Yeah, possible. Due to this assumption, we can use this simple way to define the selection bias. Otherwise, maybe you can consider it's very complicated. Yeah, it's possible. I haven't noticed that. Yeah, it sounds interesting, but I am not really sure. But it's possible due to these assumptions, it simplifies a lot of things. Yeah. Okay. Any other questions? But this just I just want to emphasize it means treatment group and control group, they are actually is not the same, except for the treatment. Even they have the same treatment, they could be different. Okay. So in this class, in this course, you will learn a lot of identification strategy. That is the causal inference method. So when we say identification strategy is basically this will tell you what can we learn about the causal effect from the observed data. Because the researcher can only use the observed data. We never be able to use something unobserved. By definition, it's unobserved, so we cannot use. So the main goal of the method we will learn in this class, the identification strategy, is trying to eliminate the selection bias. And then we can use the observed data to recover the causal effect. And the identification strategy basically has some trade-off. It depends on some assumption. And some assumption under some condition is very convincing. So we will say such identification strategy is very good. It's a good identification strategy. But some identification strategy maybe depends on very unconvincing, unplausible assumption in all the conditions. So, and I would say this identification strategy can give you some causal effect, but it's under very strong assumption, very unconvincing assumption. And that could be a bad strategy, but maybe you don't have another strategy, you can still use that. So in this course, you will learn some good strategy and also some bad strategy, but I just let you know you can apply in any kind of situation. Okay. And one thing I would like to let you know is when you study the statistics or econometrics, mostly they focus on the estimation strategy, not identification strategy. So estimation strategy is trying to help you to estimate for example, the coefficients. So you can use a lot of methods to estimate this coefficient. For example, ordinary least square, OLS, maxima likelihood, MLE, or GMM, general moment moment. This is estimate strategies. But identification strategies is upper, is trying to tell you what does the beta mean, whether your estimate can represent the causal effect or not. Okay, what does the effect, the number means? And if you know the effect, if you know what does this number mean, then the following question is how to get the number. Okay. So in this class, you will know is more on the identification strategy, like difference regarding discontinuity, not how to calculate, how to estimate the coefficients. You will focus on what this coefficient mean. Okay. So whenever people say what is your identification strategy, it's equal to what are the assumptions allow you can claim you can get a causal effect. Okay. So basically, each identification strategy will have their corresponding assumption under specific condition. Okay. So any questions? Okay. So start from next class, we will introduce at least 7 identification strategy that is commonly used in the economics. So first one is randomized experiment. So you will learn next class. Okay. So any question? Okay.
So any journal that's been written in the past like 10, 20 years are all using identification strategy and not estimation strategy?
Yeah, basically, 20 or 30 years ago, they more focused on how to estimate, and now they shift how to identify.
So like all of them use identification.
Yeah. Now it's identification strategy. Yeah. Because only identification strategy can let you know whether this is causal or not. Any questions? Okay. Okay, so the next is for your term paper. I would like to introduce several data sources that can help you to start a term paper. Okay, and how to and figure out what the research question you want to ask. And there are several data sources. I will introduce each type. The first is survey data and cross-sectional type. Well, that means we do not follow the same individual household or firm over time. Or it's just each year we randomly assign a sample and represent the country's condition. Okay, that's the cross-sectional data. So in Taiwan, all the survey are from the Academia Sinica, 中央研究院. So you can go to this website if you are interested in their. You can go to the website, and if you want to get data, you need to become a membership. But it's very easy. You can directly you can just submit, and then you can. They have several types, so you can just click. Or if you directly know the survey name, you can just put the keywords. And there are several surveys. They have the English version. Also, they have English version. Also, maybe I should show the English. sorry. So the English version, so you can, but some only have Chinese version. So that's for the foreigner maybe cannot really use that. But there's several have English version, and you can click that you want. For example, this, and then go to here. It will give you several information without becoming a membership. You can just click get a questionnaire and a code book. Okay, so that's one source. If you want to do something related to Taiwan, and if you want to do something related to U.S. or other country, especially for U.S., you can go to this website called IPOMS. And they will give you several data set that I will introduce later. And maybe you want to know the US census. You can go there and get the data. So it's not very hard. You get data. Oh, you also need to become their membership. So you need to log in. Okay. And then you can click the item to select the variable you want, okay? And this also lets you know which year, whether the year has this variable. So the cross means they have. Okay. And then you can view the card to know what you get, and also then you can create the data extract, and you get the product for free. There's no charge. Just become a membership. Okay. Okay, so if you have any question, you can just let me know, please. Okay.
It's only for the, you said it's also for other countries.
Oh yeah, they have the census for other country. Let me show. It's not just U.S., but most are U.S. Let me check. But I will also introduce some developing country or developed countries data set. For example, international one. It cover 100 countries historical census. So if you want to know other country or do some international comparison, that's also good source. Yeah, so very similar format. Yeah, you can get. And or you can select sample. There's another select sample, and this will list the country and years they have, and you can select. Yeah. And it's the census data. Okay, so any other questions? Okay. Okay, so for Taiwan, I introduced several data sets. One is census data, population and housing census. So every 10 years, Taiwanese government will survey a whole population to get their basic information about the age, occupation, living, township, something like this. But this data set, they do not have wage, actually. It's quite important, but they don't have. And also, it does not have the English version. And only the professor in the academia senior can download it. So if you want to use this data, just let me know, I can give you. But other data set, people can free use if you become the membership of the survey archive. For example, the manpower utilization is the it's kind of like labor force survey. So it's basically asks a lot of important questions about labor economics, like your age, what industry you are working in, and monthly wage, working hour, whether you have part-time job or not, print size, something like this. And it's from 76 to now. Every year, they will survey individual about 15, around 60,000 people. Okay, every year. And that's for labor force. And if you want to, if you are interested in family consumption, household consumption and income, you can look at this data set. It's basically records in household how much they are spent on the specific item like clothing, transportation, healthcare, a lot of things, social insurance. So that this will give you, and also have the household income for each household members. Okay.
So a civic college, mostly maybe they don't have the latest survey questions, and maybe it might be like 106年或107年都是比较早期，还没有近年的，那这样子就会建议我们是用他们比较旧的资料吗？还是
Yeah, 可以啊，你用旧一点资料。So she asked, some survey may only have the, do not have only have earlier wave of the survey. So in that case,
update or have a latest.
Yeah, but it depends on your research question. Maybe your research question is try to estimate the effect of some policy happened in 20 years ago. So you don't need the recent years survey, right? In that case. So but maybe you want to know like the COVID's effects, but they don't have the data around after 2020. That means you cannot really do that using that data. You need to use other data source. Yeah.
So it's okay to use the earlier data.
So it depends. Yeah. It depends on your research question. Yeah. Any questions? Okay. So Taiwan Social Change Survey. If you want to know some effects on the social, social value or the value. For example, you can use this Taiwan Social Change Survey. For example, this survey in each year they have different thing. And something is about national identity. So they will ask a question about whether you think that you are Taiwanese, Chinese, or both, something like this. Or sometimes it's about religion, or some social value, whether you support gay marriage or not, something like this. That's something you can use. And it also have the English version. And for the US, current population survey is very similar to the labor force survey. So you can also consider use if you want to look at the US issue. And American time use survey is also quite interesting. It's by its name is the time use for each activity on each activity. Basically, it's select one family member from the CPS household from this survey. This survey asks all household members their wage, their marital status, their health insurance status. And they will select, for each year, they will select one of their family members and ask about their time allocation. That means how many times they ask very detailed, from 10 p.m. to 6 a.m. each hour, what activity you do. So maybe you are all, during that period you sleep. So you need to record you are sleeping. Or maybe you play with your kids. They will record like this. Okay. And this will link with the CPS data to get more information. So it's quite interesting data set, the American Time Use Survey. And National Health Interview Survey, if you want to focus on something related to the health, like the effect of smoking on health status, for example, you can use this data set. It gives you each individual the samples health condition and health behavior and healthcare use. Okay. And higher education survey is focused on the undergrad students, and they also will know their employment status after graduation. So that's something you can, if you are interested in the education issue, you can, especially higher education issue, you can use this survey. Okay. And for the developed countries, there are several survey data you can get from the IPONs. Yeah, that's the international, IPON International I just mentioned. And there's another project called North Atlantic Population Project. It has Canada, Denmark, UK's from 1970 to 1911. There's a census data. Okay. And there are multinational time use survey you can also use. So not only US has time use survey, UK, France, or other developed countries also have time use survey. So maybe you can use this explore the COVID, but I don't know whether they have very recent time use, but COVID might affect your time use. And other countries, especially for the developing country, you can use the World Bank survey database or this demographic health survey. That survey is quite amazing. It collects around 100 countries, especially from Africa or Latin America. They ask the question about the health and population issue, okay, in the developing countries. So if you want to examine some issue in the developing country, you can use this DHS data set. Okay. So any questions? Okay. And there's another survey if you want to do some international comparison about the human capital using the standardized test data. Basically, each year they will select some school or some class in each country to ask them to to have the test, and this test question is the same all around the world. So they release the data PISA test. There are two type tests. It's called one called PISA, one called TIMSS. So that's something you can explore if you are interested in this issue. Okay. And the survey we discussed so far is cross-sectional data. That means we do not follow the same person, the same individual over time. And there are several surveys, they do follow the same person, same household over time. That's called panel data. So for the panel data in Taiwan, we have two big panel data. One is panel survey of family dynamics. This panel data is start from 1999, and they follow the same household over time, even follow their offspring. So after their offspring become, after maybe when they are 18 years old, 20 years old, they have another family. They also follow their household, this household. Okay. So from 1999 until now, they actually follow the same household from 1999, follow them from like 2 or 3 generations. So this data set is quite complicated, but it's also quite interesting. So they have the household income, education, working experience, and even they have family value, some value or attitudes questions. Okay. So this 中文是那个华人家庭动态调查。Okay. And Taiwan Education Panel Survey, if you are interested in Taiwan's education, they follow the same students when they are junior high school and senior high school in 2001, and follow them until they have job. I guess you follow until now. They ask questions about their working experience. So follow them from their teenager to when they are become adults, 30 years old, 30 or 40 years old.
Next, I want to ask what is family value and attitude.
Oh, this? Oh, it's about, for example, they might ask question whether you think females should work at home, or should stay at home or not, something like this. You agree or not? A female should stay at home, male should go to work, something like what is traditional value. Yeah, especially for the Taiwanese traditional value. Yeah, they might ask. But they also ask several other questions. So because a lot of researchers participate in this project, so different year they might ask different questions. So it's not necessarily the question related to family value, but also others. Yeah. Okay. Any questions? Okay. Okay. So tabs, if you are interested in the Taiwan's education, you can also look at, because they have also have the test score, the standardized test score. Also they know their network, friendship. And also they have questions for their parents, teachers, and school. Okay, and they follow them until now. Oh, 那个台湾长期教育追踪资料库。对。Yeah. So. Yeah. And for US, there are several panel data sets. One is panel of income and dynamics. The panel income dynamics actually is, I forgot, okay. This is very similar to the Taiwan's panel survey of family dynamics, because this survey actually follow this US one. This US one is start from 1967. So they actually follow the same person maybe around 4 or 5 generations. So it's more, have larger data set, a larger sample size. And if you want to look at something related to health and retirement, you can also look at this panel data. this data set this survey basically survey the people who are above 50 years old, so they're quite a bit middle age until they die. So it's a health and retirement survey. So it's combined the question about labor and health. And if you want to look at some teenager issue, you can look at these national longitudinal surveys. And also, if you want to focus on the low income, middle income people, survey of income and program participation could be interesting. And this is for the healthcare utilization. Okay, healthcare medical expenditure panel survey. Okay, and all of this they follow the same person over time. Okay, any questions? Okay, and survey data, but now several people might use administrative data. And administrative data, they have very good advantage is they cover whole population in Taiwan or in US or in other countries. And originally, administrative data is not for a research purpose, it's for administrative purpose. For example, we have some administrative data in Taiwan, like health transaction data, 实价登录. So originally, this data is trying to slow down the housing price growth. So they want to release this housing price value, the real housing price. So each transaction after 2012 will be recorded in this data set. So you will know exact address of that house, apartment, and which when they have this transaction. So it's very detailed information. And it's public available because it's not related to any human beings or any privacy issue. So it's public available. And you can download from this website. But it's not very, you can download using several web crowd, using some technique to do that. But you can also directly buy it, but it takes like 3,000 or 6,000. So if you want to use this data set, I have already bought this data set. You can just let me know, I can give you. Okay. And data on mortgage is also, for US, if you are interested, it's also public available. And some administrative data is not public available. That means you need to go to the data center because the data is quite confidential. It has some privacy issue. For example, the National Health Insurance Research Database, 全民健保资料库. It's basically, since Taiwan has national health insurance, so the government want to use this database to calculate the revenue and how to determine the premium and what's the expenditure of the NHI. So that's why they have this database. But this can also very important, good for the research because this database record each doctor visit. So when you visit doctor and what's the diagnosis and what's the cost of each visit and the copayment and other things. So, but you need to go to the data center, yeah. And the data center only available in Taipei area is only in the Academia Sinica and National Taiwan University. So it's not in National Chinese University, but that's fine. So I don't recommend you use these to write term paper.
So because like Taiwan, everyone has NHI, so you couldn't really like place that as kind of like the origin of the child because there is no control. Because we all have to have NHI.
Oh yeah, you raise a good point. Yeah, that's the thing we will emphasize a lot throughout the semester. Try to find a good control group. Someone do not get a treatment. Yeah, you are right. Everyone covered in the NHI, so you cannot really examine the effect of having health insurance on healthcare utilization. But you can examine some issued using some policy change. For example, NHI, you don't need to pay any co-payment if you are under age 3. If you're just above age 3, you need to pay a co-payment. So it's possible you can explore the effect of co-payment on the healthcare utilization, something like this. It's still, but some issue you cannot explore under this condition, situation. Yeah. So, any other questions?
En la academia cívica donde no viene database about corruption, things around, donde blog. I mean, you have any information about corruption?
Corruption
Yeah.
in the survey?
Yeah.
Oh, yeah, there's a survey called Taiwan Democracy something survey. That's you can get from the data center, the survey website I mentioned, but I do not introduce. But that's something you can do. It's about some, if you are interested in political economy or politics issue, it might have this question. Yeah, but I'm not sure whether they ask corruption. Maybe they ask, do you think the Taiwanese politicians corrupt or not? Something like this. Some question like this. Yeah. Any other questions? Okay. And tax return data is also confidential data. You also need to go to the data center. It basically cover each individual's their income and wealth. So you can, if you want to use this for your research, it's possible you can try, but you might need to have a bit long-term plan. For example, maybe you just get very preliminary results in this semester, and then you might use that for your thesis. It's still possible, but I'm not sure whether I encourage you use this or not, because you need to go to the data center. And this is very big data set, very big data set. But if you have some research idea or question about might use this, you can let me know. I can try to find some possible way to let you do some data analysis. Okay. And for the sports, there are a lot of data set about the sports, and it's administrative data because originally it's for the team. They try to understand their players' performance, but they also collect. For example, you can look at okay. It has a lot of statistics on the player level, like basketball as MLB, and basketball NBA, or is it for US? So this is US league, yeah. But that's something you can. So they have player level, and you can consider each player is kind of like a worker. So it's kind of like do something related to labor things. And the Yelp is a company who publish the crowd source review about the business that give you 4-star, 5-star. So they have they publish some data about the business, the review on the business, and that's something you can try to look at. And Google mobility data and Apple mobility data is after the pandemic, the Google and Apple, they actually publish the mobility. That is, they create an index to show within this area, for example, Taipei City, the growth for go to the workplace or go to the park. So they have this data set after the pandemic. So you can look at this if you want to know the effect of the COVID on the mobility. Okay. And Apple also have, because Android and iOS, they both cell phone either in these two systems. So they have this data set. They aggregate at the city level, okay, or country level. Okay. So any questions for this? Okay. So I think we can have the break. Okay. And then I will finish this.
但是我所知道的是用过，然后那个就是在全民电脑资料，然后他说他就是有其他老师有拿，然后如果我的研究论题是跟他有关的可以用，其实应该就是他那边可以。
他可以。
对，就是
哦，可以啊，当然可以啊。就是我不推荐用，只是因为我怕你们找不到管道用。对，但是我这边也有，所以你们真的想用可以，也可以用。只是那个就是它进去有一些时间或者是人数的限制，所以就是真的很必要才会使用。但是如果你有自己的管道，当然就很 OK 啊。对。整个台北都在下，应该不是只有正大。
桌子那么小，然后左撇子就翻车，应该是高层。
你们是不是刚刚上面没有？你说跟贵妇比的生活吗？我这样，下面那个105跟是你会哭吧？我是第一届用那个教室的，他们每一个椅子上面都会刻一个人的名字，然后每一个名字都是谁的那张套，你知道吗？然后就是就是MBA 嘛，就是 MBA，然后就是一个他们好像是走山，就是山路，他们去长崎，然后走一个像马拉松的，然后他们那个时候80几个人，然后回来就带了那个小小教室，分2个室，然后就是80几个人，所以那个教室的人那就是82，就是那个刚去年发的，然后那张椅子上面真的是尊贵不凡的商业。我是第一个用那个教室，它就105嘛，对，它就是四面，四面都可以写。四面都可以说就是说黑板。然后最右边那边就列了全部他们的，然后每个椅子上都有规则。
像那个什么庙里面有没有？不是？
对。
都这只狼是谁刻的？然后就是。
然后我那时候就是上那堂课，因为我上的那一堂课那个老师他们会计系很权威很大的老师，他们1节课跟我们讲1节教室。你刚被你讲没有课那个东西，我瞬间就这样。
反正就是啊，然后那边讲历史，所以这个是谁捐的？我没。
我那时候本来要。
我们学校好像就是一个人就捐1栋楼，所以说就没差。
请问1个人捐1栋楼是什么？
就是什么什么董事长，怎么有钱？
好，记得找我上课的时候，我在咨询上，然后老师一直跟我讲，然后去看那个书，
他什么？
他那个女儿去看是毕业的科那个，但他说，去考那考研刚一上对，你知道他那这张楼层怎么变成了名字？
因为CFA 那么好考，还很美哦。
太笑死了！
我很狂第一个课我就考不过，新型3是加微积分。
我觉得以经济系学一考试，我觉得很容易啊。我觉得非常容易。比期中考甚至小考都还要简单很多呢。
他们说第一个是数学系考的，要考微积分。
很难，真的没有很难，超级简单，真的。
我上活动课上去哭出来。
没有看到他的题目，真的超级简单。
我没有看过。
真的，我是上才想回来，然后我哥那边讲的，
这不很难，超级简单。
他们说哪门课第二
对，level 2比较麻烦。
可是你就想一想，一次报名课你就不会想，
贵，超
对，
贵
就。不会想去。
重点是这个，对，
一次报名费多少
1000块美金吧。
是啊，对啊。
这里面就是没有，就是什么数量方法、期末考，期中考、期末考，觉得里面的难很多。
我就想上那个。
那个猫咪很像被打那个马赛，眼睛被打麻将。
你知道我之前上那个世界训练之后，我就心里想，
我没有上，我没有上，
我对不起你，我那个微分方程不学去哪里？
我完全不会，他更不嫌弃。
然后学起来之后，是因为你找到动荡指导是你要接触上体验。
哦，那可爱。
不学校的定义。
就是啊，你是在华吗？
很多皇阿玛，
一起
皇阿玛真的很肥。
肥宅猫的感觉。
啊哦，是晚上，其实我分不出来那些猫，
因为它有腹肌耶。它是偏超级。
我知道皇阿玛就很肥而已。
而且还有手，它是比较瘦的。
还有什么三角猫？对。
听说你们寒假接放纵的那个很可怜。
可怜点是因为我们被挡趴，所以我们就没办法，然后老师就很无奈，说然后后中就真的帮我们检查那个网页程式嘛，说他真的挡趴怎么办？然后他说你们至少要手动自己下载。然后我们现在要下载国贸局的资料，因为国贸局的资料又没办法用它，因为你又要去验证嘛。
还好我没有去他的那个，真的好险。
唯一的好处就是老师我可以找到老师妈妈的前提，但唯一的好处就是这样。
你找其他老师也是记录那个吗？
不会，
你找信实马上签，找国军马上签。
信实不要，5个我觉得。
对，他其实好热门嘛，对。
不是信实，他昨天终于回我信了，我还是寄信给他女朋友。
我传他讯息，他都秒回。
因为我每次看那信就哭出来，所以到底什么时候才会回我信？
哦，
然后每次去演示很少。
我们会提示，因为
好漂亮。
这个讲完就讲，
也没什么好考的，因为就，然后我觉得硕士班也就没差不了太多。
我只想毕业，我一直在说，就武大学，最近有很多新会，很明显。
还是毕业要赶快就不见了。不是啊，你要做什么？不觉得这样是很
无法，我就喜欢平凡人生。
哦。
没有，我觉得不感动。
就像那个是人说的，不要想着毕业就去
对，我就想到。
Okay, so let's continue. So far we discussed is either the individual level data or household level data or household level data. So it's also some data is about the firm. So the firm level data that you might consider. So for example, if you want to focus on some corporate finance or some firm level issue, you can look at, for Taiwan, you can look at the Taiwan Economic Journal, the Taiwan 经济新报. And It's a database of the financial and market information on list company at stock exchange market in Taiwan. 就是上市贵公司而已。Or in Hong Kong, China. I think the business school might hold this database, but I'm not sure the College of Social Science whether hold this database or not. But I'm sure the business school they have. Okay. And CompuStat US is for global US. It's the same, very similar, but it's just focused on the global companies, also big companies. And I think business school should hold this database. And you may go there to use, or go to their library. You should be able to use. Okay. And there are several data is country level. That means maybe you want to know some effects on some microeconomics variable like GDP or money supply or other things. There are several like Penwell table. It has the around 200 countries GDP from 1950 to 2019 or 2020. So it's covered quite a lot. And World Wealth Income Database, it has a lot of information about a country's wealth equality or income equality. So the data usually we have is the GDP, the level, on average, how much people earn. And this is about the inequality for each country. Okay. And there are several data also have the GDP or other data, but maybe in a more detailed way, like OECD data, or this is for European country, and Fed economics data. That's something you can use. And government open data is another data source. Like a lot of government, they have the open data because there's this movement of the open government. So US have open data, Taiwan also have, and they collect a lot of aggregate level data sets you can use about transportation, population, or healthcare. So that's something you can also use. And there are several geographical data, and we will discuss how to handle the geographical data in the end of semester. So here I just give you brief idea about this data. For this website, you can get the map. You can draw the map for each country's administrative area or their subdivision, like county, states, or township. They provide the shapefile. You will know what is shapefile in later class to create a map that can help you to generate a map. And this data set is quite interesting. It's geographically based economic data. It's constructed by a research team in Yale University.
This website also has Shapefile, for example, city division. But for example, let's say Latin American cities. Sometimes I try to find some shapefiles of my city, of their neighborhood division, and I couldn't find anything.
Here, this website.
Here?
You mean you ask whether they have?
Yeah,
this?
whether they have. Maybe for I know that
very
maybe for European
detailed. I don't think they have, but they might have at least county level. I think they have state county. I know in Taiwan. Taiwan also in this website. We have the township level.
Oh, okay.
Yeah, but I don't know bigger country. Maybe they may not have more the detail level. Roughly like state, like US. I think they don't have township. They have county.
Yeah, they have
because
county.
US has 3,000 counties.
Yeah.
Taiwan only have 23 counties. So for each country they may have different level of the detail. Yeah. Okay. So any questions? Okay. And this geographical base, economic data is developed by this Yale professor. Basically, it collects a lot of source of data, and they publish data based on the geographical area, not the administrative area, not just country. It's based on the geographic. That means they publish the data set based on the location, and each unit is 100 kilometers times 100 kilometers. So this size. So it's not based on the country level or county level. It's based on the definition, based on their geographical definition. Okay. And they collect this data for this type units for the population or night lights or GDP, some estimate for GDP in 2000 to 2009. Okay, so that's something maybe you can use. And there are several data is based on the satellite image on the land cover, land use, or atmosphere or ocean condition. So it depends on what you want to use. There are several satellite image. And why satellite image can use for the economics analysis, because this satellite image basically is image, but you can use R to read this image. And this image actually has a pixel records the number. So the number might imply different things like pollution or nightlight, something like this. So you can analyze, and we will discuss how to do that in the end of the semester. Okay. And this is a satellite image for nightlight, and this actually used a lot recently in the economics research. Basically, we use the brightness of nighttime light to represent the economic development. So you can consider if the country does not, the GDP is not very high or the growth rate is very low, they will become darker and darker. So it's kind of like use that as a proxy for the GDP growth. Okay, so that's the source. Okay. And there are several journals will also publish the data for their paper. They require the author has to submit their paper, their data. For example, the American Economic Review or AEJ, these are very important journal in the economics. Basically, you can extend their analysis. So your research question could be based on their research and do some extension. And maybe you can use their data provided by the journal. Like for example, you can click like this paper, political turnover something, and you can read their paper. Read their paper, and they have data set. So usually it's additional material, so you can download data set. So maybe the author examine the effect on this outcome, but maybe you think examine other outcome also in that data set is also interesting, but they do not pay attention to. That could be possible good extension. Okay, so that's something you can do. And other data source you can just explore by yourself. I just list here to let you explore. So any question for the data source? Okay. So let me know if you want to make appointments, discuss with me about your research idea. But at least you will have 2 compulsory office hours with me to discuss your research idea. Okay. Okay, finally, I would like to give you some brief introduction to this data. And yeah, you can try to find how to get this data, but I can also try to let you know how to get it, okay? And so Stata is the statistical programming language, and you can use Windows, Mac, Linux to in this type OS you can use Stata. And there are several versions of the Stata. Stata IC, Stata SE, Stata MP. Basically, it's based on whether it's powerful or not. The weakest one is Stata IC, and the powerful one is the Stata MP because this version can do multi-processing, so it can calculate faster, and also there's no limits for the number of variable. Okay. But I would say the MP and SE are all enough for the research. Okay. So the typical Stata interface looks like this. So I just directly open the Stata to introduce. Okay. You can see. You can type the command here. So that is something you type your command. And you type the command, the result will show up here or other place, or open another window. So for example, you can help use, and you type and you can get this. This command teach you how to use specific command. That's just example, but you will learn how to use that later, in the later class. And so this is the command, and the result will show up here. And this window gives you the history of command. You just type. So you just type this, so it will show up here. So if you click here, it will show up again in the command line. Okay? And if you open the data set, it will show up the variable in that data set. So how to open the data set? You can just click here. Okay. For example, here I click here. Oh no, this is not data set. This is a do file. For example, you can open the data set. So open the data set, you can just open the data, and data will load in here. This will show up the variable in that data set, the variable name and label. And how to open a data set? You can just open here. It will open the data set. So there's the data editor. Data editor. So this is for browse. And this is for edit. So if you click this, you can edit the number. But I don't suggest you do that. Don't create a fake number. So the browse, typically if you want just look at the data, you can just browse. Or you can type the control 8. Also can have this. If you type control 8, it also directly give you the data browser. Okay. And this will show up each variable, the variable value. Okay. Okay. And another thing is this is the folder that stores the result, the result kind of. So this you might change to you might use some way to change the folder, but I will let you know how to change the folder in the next class. Okay. So any questions for this? It's just brief introduce the window in the Stata. Okay. Okay. So another important thing I would like to let you know is do file. Do file. And because there are several ways you can type your commands, but I would suggest you use a do file. So what is do file? I will let you know later. So there are several ways you can type your command. One way is like interactively, it's like doing like Excel. But I don't recommend you do this because if you do this, every time you want to get the same result, you need to implement the same process, spend the same time, a lot of time to just repeat the same action again and again. It's not very efficient. So, but I still let you know how to do that. You can do like doing Excel to click here. For example, you want to do some linear model, linear regression. You can do this interactively. But don't do that. Don't do that. That's not very efficient. So you can do this like I want to use linear regression and type your dependent variable, what's the variable name, what's your independent variable. You can do that. But if you do that, every time you have to do the same things. It's not very good. So another way to type your command is you type in the command window. That is here. But each time you just type one line, one command, and show the result. It's also not very efficient. So the thing I would suggest you should do is using the do file. So basically you type every command you want to implement in that file and store. And next time you can implement the same command lines again and again. So you just do once and next time you just implement. So it's like programming. So it's like other language. You basically you write down every command in a script. So like R, you have R script. So this do file is like R script. Records the thing you want to do. Okay.
So for your homework, like this, like what is gonna be like the format of the homework? Like will you ask us a question like maybe we have to do like a regression and then you have to like screenshot the data output?
No. Actually, the homework is also help you to do the research or term paper. The homework actually, the answer is depends on each people have different answer because the homework is the typical question is using this command to do something. For example, using the command create a new variable for your research. So you just type the command, explain the command, and show the result. That's enough. Yeah.
Do we have to document all in the do file so you can see like our process with our data? That's how
that's you need to submit the do file. Let me know, or copy the do files content on your answer sheet. Yeah.
So something like this or the actual do file command, like we have to screenshot like this output.
That's something I will introduce next time. Is there's another file you can create called log file. Log file basically will records each result you generate. So you just submit, I will know what you done. Okay, yeah. Any questions? Okay. So what is the do file is here you can open the do file by click here, or you type Control 9 can open the do file. And you open this is the empty do file, and you just type the command you want to implement. Okay. So for example, let me check. Yeah. So you will, for example, you type the do file like this. And if you want to implement the command, you can just highlight this, and click this. It will implement. So basically, this is implement execute selection. So you can select the command line you want to implement and press here, and you can implement. Okay. And the data will do something. So originally they have some data here, right? But I say clear. Clear is the clean all the data. Clear the previous stored in the data editor. Clear, yeah. And then you can do the following things. That's a typical thing you will do in this data. So the typical format of do file is like this. You will have clear, because typically you want you might already have some data set stored in the data, and you want to clean them. And then you will type this, stay more off. And I will explain what is this. And then you will type your own data commands later. So first command is clear. It's clean up any previous data. Otherwise, you cannot load a new data set. Okay. Another is set more of. Why we need this command line by default is because data when you implement very long command line, you will have a lot of results show up in the result window. And data actually is quite kind. They know you cannot read the result if you have too many results. So they will pause. The data will pause, will stop. So this command is try to avoid this situation. If you type this, the data will not pause. Data will just go through the result. And so it will avoid maybe before sleeping you implement a lot of commands. But if you do not type this, the data will just stop at a certain moment. And then the data do not be anything for you after you wake up. So usually we will put the state more off in the very beginning to avoid this situation. Because you can get all the result by using the log file. You create a log file. And I will let you know how to create a log file that can record every command you type and every result generated by the commands. Okay. So basically you can store all the results in the log file. Okay. And final thing in today's class I would like to let you know is how to put your notes in the do file. So that's it's a good practice to keep the notes within the do file. It's good for yourself because sometimes you don't know why you want to do this command. And these notes can let you know, give you some memory to know why you want to do that. And it's also good for collaboration for your co-author or for your supervisor to know what you're trying to do. So you should put a note. Try to put note for some commands which may be a bit complicated. At least for such commands, you should put. And there are several ways to insert the command in the do file. I just open the do file. The first method is you type 2/. It will become green one, and data will know this is notes, not the command. Okay. So if you do not type the 2 slash, it will change to the command. But this is not command, so instead I will show up some arrow thing. Okay. So you type 3 slash, it will become the nodes. Okay. Another method is slash plus star or star slash. So you can, this is especially useful when you want to make some area is you don't want to implement that command line, or you put some very long nodes. You can do this slash star slash within this area, this session. Stata will know this is a nodes, or this is the area you don't want to implement. Okay. So if you want to implement that command, you can just eliminate the star, and Stata will implement. Okay, so that's the method 2. And method 3 is 3 slash. 3 slash will have important, you can put 3 slash, it also knows the nodes. And another useful thing for this 3 slash is it will make 2 lines, say I will think they are belong the same command line. Because sometimes you might have very long command line, and you need to put in the same line, otherwise they will have some error happen. For example, actually these two are the same. It should be in the same command line. But if you type like this, Stata will have some problem happen. So you can use, but you don't want to write down very long command line. You can use 3 slash, and Stata will know this line and this line are belong the same command line. Okay. So that's the 3 slash. Where we use this 3 slash. Okay. So any questions for this? Okay. So next time we will discuss the identification strategy 1, the randomized experiment. And also for data, I will let you know how to read the data and do some data management. And you can go to my website to get some do file and data set to this link. So basically the link, you can get the do file and the data set. And also I will put some useful things in the link. Yeah, so any questions? Okay, if not, that's all for today's class.
So the 3 slash is more than a comment. It's more of a way to just combine the two. That's it. So,
yeah, actually 3 slash is not just for the notes. Actually, the main goal of 3 slash is combine 2 lines of the same line. They make Stata think, no, these 2 lines are the same. If you don't put a 3 slash, Stata will think they are 2 different commands. Well, and they will have some error because there's no command actually happen in the second line.
So that it's more than a comment, making a comment. It's just like it's for the program.
Yeah, okay. But 3 slash can also represent the notes.
Okay. Okay.
Later on, you will email
对对，但是我在想怎么再安全一点方法。对，但有可能就是我会帮他们抓画连接，然后大家学习啊，这样子。
因为我想说，好像要边操作边
对啊，所以
但效果。
对。
大家等着看隔壁同学的。
对，所以我今天没有开始怎么讲，就是讲大概。
那老师发上去他会红。
会。
I'm looking forward to the sun. I haven't seen it in weeks. It feels like forever.